Hey, how's it going, guys? So today I'll quickly go over my solution to LeetCode's graph value tree problem of 261. Okay, given n nodes labeled from 0 to n minus 1 and a list of undirected edges, each edge is a pair of nodes. Write a function to check whether these edges makes up a valid tree. So example 1, we're given 4 nodes, so node 0, 1, 2, 3, 4, and edge list as 0, 1, 0, 2, 0, 3, 1, 4, and we output true because it's a valid tree. So I draw the the graph here, so you can see that 0 is connected to 1, 0 connected to 2, 0 connected to 3, and 1 connected to 4. And we can see that this is a valid tree, right? Although it's not a binary tree because it has like 3 branches at here. It's not a binary tree, but it's still a tree. And this I drawed example 2. So we are also given m equal to 5, so 0, 1, 2, 3, 4 as our nodes, and our edge lists are 0 to 1, 1 to 3, 2 to 3, 1 to 3, 1 to 4. And your graph looks like this, and it's not a valid tree because we know in the tree there should not be any cycles, right? So basically, so the question asks us to output true if it's a valid tree and false if it's not valid tree. So we output true for this and output false for this. And we can see that if there is a cycle, it's not a valid tree. Okay, so this question becomes a cycle detection problem. If there is a cycle in the graph, output false. If there is no cycle in the graph, let's say here, we don't have this edge. Is this there's no cycle in the graph? Is this a valid tree? No, it's not, because it's not connected together. So our two condition is 1, no cycle. 2, 1 connected component. Okay, so these are the two like a determination or 2 criteria for not tree, for a tree. Okay, let's first think about how to detect a cycle. Because detecting whether it's a connected component is very easy, because we can just traverse the tree using like a DFS or a BFS and then mark each node as visited. And at the end, we just need to return whether the node, the set, the visited is equal to n, to the number of nodes. If it's the same, like for this example, it's the same, it's 4, then it can be one connected component. However, if it's like here, and when we traverse this, it gives us 3 visited node in the set, and 3 is not equal to n. This will give us 4. It's not equal to our given n, which is 5. So we will return false in this condition. So that's easy. So how the most important question in this question is, how can we detect a cycle, whether a cycle exists? There are many different ways. There are union-find, DFS, and BFS. Today I will just introduce the DFS. I think it makes sense. So what that do is that first you create the graph, right? Because we are only given edge list, and it's not easy for us to know the node's neighbors. So we'd rather create a graph. So it's marking the node to its neighbors. Yeah, so that's what I did here. And once we done that, we just need to do a DFS. And this is just a DFS like a template. So how does that work? So basically, we have a stack, and we append the 0 node to the stack. We append the node and its parent to the stack. So for example, when we visit here, we'll mark 0 minus 1. 0 being the node we are currently at, and minus 1 being the parent. And we initialize the set as an empty set. So we pop while stack, and again, this is just like a DFS basic template. So if you're not familiar with DFS traversal using a stack, then you probably should watch more tutorial on that first. So basically, we have a stack, and we say while stack, we pop the current element and its parent out of the stack. So right now we pop 0 and minus 1 out of the stack, and we add the current node into the sync set. So we mark this as visited. Okay, so and we go back to our graph, and we get all the neighbors. And for neighbors in gcurrent, so we get all the neighbors out. So if the neighbors is not seen, we add it to the stack. This is again like the basic DFS template, right? So like here, because one is not visited, then we add it into our stack. We add the neighbor itself and the current, meaning the parent, because right here for 1, 0 will be its parent, right? And because it's a DFS, so it will traverse to 2 for the next thing. So here we add 2's parent, which is 1.